Too much time had passed where I didn't have a nice workbench set up. This digital audio recorder was literally breadboarded while I was still living in Arkansas sometime in the year 2016. Now is 2018. And I'm going to be disassembling this. But before I do so, I'll make a video of its operation. This is very similar to some digital audio recorders that I had built, of course just breadboarded, in 2014, this one being 128 kilobytes, but not very good quality. So let us record something.
This is digital, by the way. This is digital, by the way. By the way, 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 by the way. By the way, by the way, by the way, by the way.
Right.
This is digital.
Faster sampling rate. It won't be very long.
This is so freaking digital, oh my gosh.
Obviously the whole thing wasn't recorded, but lower.
This is so digital, this is so digital.
Okay, I'm going to show a basic schematic. Now this isn't comprehensive, like it doesn't show all the pin numbers and all that stuff, but it's very basic. We have condenser microphone and its resistor, which is just 10K. A 741 op-amp based preamplifier where I can adjust the gain. This is done very simply, of course. I'm just doing this in kind of a hurry to disassemble this thing. A low pass filter. No, I don't know the cutoff frequency of it, but it muffles the sound a lot, with a bunch of 470s and a bunch of 0.1 microfarad capacitors. So it's like fourth order, I think. And then analog to digital converter, 8-bit. Trimmer to adjust the sampling rate of the analog to digital converter itself, different from the actual sampling rate of the RAM. I didn't have as much, at least the values I had, I couldn't make this go as low as I wanted to. So I had a separate clock from a 555 and then the ADC's internal clock. An 8-bit DAC, an amp on the DAC, and then the same low pass filter arrangement, 470s and 0.1s. And then of course this is all on the data bus. Of course the write and read is simply selectable with a switch as to which one is done low. I didn't draw that on there. Reset, push the button and it pulls reset low, so it's no longer resetted, and the chips are allowed to clock. They're just 4040 12-bit counters. Using all 12 bits of this one, 5 of that one for 17 total address lines for the 128 kilobyte static RAM. A 555 drives the counters. It's pretty simple, pretty basic. That's the gist of what this thing is, aside from a bunch of specific values. But you should be able to find ADC datasheets for chips and with sample circuits on how to hook them up and wire them all together. ADC 0804 is the analog to digital converter. The DAC is a DAC 0808. But an R2R ladder would work too. The RAM used here is a KM681000. But anyway, even that doesn't matter so much. So the basic thing is, this is basically what's on there, how it's operating. The digital audio recorder is fairly straightforward. Low quality, of course. Tried to improve it by having all these low pass filters. Matter of fact, I was not having the output low pass filtered right here. As you can hear it alias. Gee whiz. Go. See, actually the output right now I don't have through the low pass filter, so you hear it alias. That was actually through a first order. If we have 0 orders, no low pass filter here. Then go through the first stage of the low pass filter, we got two low pass filters. Or actually no, that's 3. 2 low pass filters, there we go. 9 kilohertz right now is the sampling rate for the actual counter chips. 3 low pass filters. And then finally 4 low pass filters. I'm going to make another recording. Switch it to right.
This is a very digital recording. The sampling rate on the actual RAM is 9.07 kilohertz. This is a very digital recording. The sampling rate on the actual RAM is 9.07 kilohertz.
And we can change our playback speed. 30 kilohertz now on the RAM. The frequency, let's check the frequency that the ADC is actually sampling at. It is sampling at a whopping, if this is actually going correct, almost like about 2 megahertz. Gee whiz.
This is digital. This is so friggin' 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 digital.
Let's bypass the low pass filters on the output. Play it.
This is so friggin' digital.
Now right now the sampling rate of the RAM is 30 kilohertz.
This is so friggin' digital.
Now, to satisfy curiosity, let's bypass the low pass filter on the input and make another recording. Go straight from here.
This is so digital. This is a digital recording.
And
This is a digital recording. 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 This is a digital recording.
sampling rate, let's make it 16 kilohertz. And
You are listening to a digital recording on static RAM. You are listening to a digital recording on static RAM.
let's filter it by a couple orders worth.
You are listening to a digital recording on static RAM.
Now, on the input, let's filter it by a couple here. Let's skip that one, skip that one. Let's go here. And then
This is a digital recording onto static random access memory. This is a digital recording onto static random access memory.
and let's unlow pass filter the output. And
This is a digital recording onto static random access memory.
fully low pass filter the input, make another recording.
You are listening to sound audio from the digital domain. You are listening to sound audio from the digital domain.
We're going to then fully filter.
You are listening to sound audio from the digital domain.
It's a rather simple device. If I lower the sampling rate of the ADC, notice how the audio changes.
Hello, 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 hello. This is a digital recording. This sounds extremely crazy and robotic-like. Let's see how this is.
And the frequency right now of the analog to digital converter is 46 kilohertz. You'd think it'd be better than that, but that's where the confusion comes in. Because Nyquist would state that that's just fine.
Hello, this is digital. Hello, this is digital.
So I don't know. But it does show that you can make a digital recorder using basic logic. Analog digital, digital to analog, op amps, and some RAM. It's not perfect, and obviously for some reason, even though the sampling rate seemed like it was much, much, much higher than the Nyquist, it was still distorted and crappy sounding, so I don't know. It's a little crazy. Maybe I'm not on the right pin, but who knows. But anyway, I hope you enjoyed this video of this, because instead of going ahead and disassembling it, I figured I'd go ahead and make a video of this device first. And I could tack onto this video some quote-unquote hits that I made using this to mess with my voice. And here's the power supply running it. You may recognize this power supply from a video that I did back in 2011 when I built this. I since replaced the transformer with a more conventional one because the homemade transformer that I made for it is way too inefficient and gets way too hot over a long period of time. So I wasn't going to have any more of that crap. It's so digital. It is so digital. It is so digital. Oh yeah. It is so digital. It is so digital. It is so digital. More than you can fathom. It is so digital. It is so digital. It is more digital than you can fathom. It is more digital. It is more digital. It is more digital than you can fathom. I am the digital man, 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 I am the digital man. I am the digital man, I am the digital man, I am the digital man, I am the digital, I am the digital good, digital good, digital good. I am a robot, I'm digital for you. This is so digital. This is so digital. Everything is so digital. This is so digital. This is so digital. This is so digital. This is so digital. Digital time, yeah.